So this is the second half of the electrolysis calculation video, and I just wanted to start with the intro screen because we're going to need these two pieces of information for the calculations we're about to do. Make sure you've got a periodic table, make sure you've got a calculator. It's a good idea to have a pen and jot things down as we're doing them together. So I'll skim over the calculations we've already done, and here we are. So we're passing a current through a copper sulfate solution. Copper, because it's a positive ion, is attracted to the negative electrode and gets deposited there, and we get oxygen given off at the positive electrode, and hopefully you know why oxygen is given off there, and that's because there is oxygen in the water which the copper sulfate is dissolved in. So the oxygen actually comes from the hydroxide ion, so 4 hydroxides turn into 2 waters, an oxygen molecule, and they release 4 electrons. So you can see here that the copper ions gain electrons to form copper metal, so it's a gain of electrons, so it's a reduction. And here the hydroxides lose electrons, they kick electrons out, so this is an oxidation. So on with the calculation. We have some information here. We know that 0.03 Faradays are passed through, and helpfully it tells us it's copper 2. Okay, and we've been given an equation there. So calculate the moles of copper that would form when 0.03 Faradays pass through. Well, hopefully you remember that 1 Faraday is the same as a mole of electrons. So your moles of electrons would be the same as the Faraday, so 0.03. And from that we can work out the moles of copper. We need to use this equation here, and if we'd had 2 moles of electrons, that would have made 1 mole of copper. So we have a 2 to 1 ratio. Now we haven't got 2 moles of electrons, we've got 0.03 moles of electrons. So because it's a 2 to 1 ratio, that means the moles of copper would be 0.015. Where does that number come from? Well, that's half 0.03. So that's our moles of copper. Now you might have predicted what the next question would be. Calculate the mass of copper that would form when that electricity had passed through. So you need to convert your moles into mass. What a surprise. You need to use the triangle. Moles is mass over relative molecular mass. So if we're converting from moles into mass, mass is moles times mR. So mass of Cu is moles, which is 0.015, times by the relative atomic mass of copper. So you need your periodic table to find this value. So I'm just looking across mine now, and the one I'm using actually has copper as 63.5. Now you may have one that uses copper as 64, but I'm using the value I've got in front of me. It doesn't matter which one you use, to be honest with you, and that gives 0.9525 grams. And that's our final answer. So very similar to the last question that we covered, but here things are slightly different. How many coulombs of electricity flow when 0.03 Faradays pass? But they've told us that 1 Faraday is 96,500 coulombs. So if 1 Faraday is 96,500 coulombs, 0.03 Faradays would be 0.03 of 96,500, and of in maths quite often means multiply, so I'll have 96,500 times 0.03, and that gives, if we just put it into our calculators now, 2895 coulombs. And that's your finished answer for that one. I'm going to change colour of pen. Next one asks us to calculate the moles of oxygen that would form. So for this, we need this equation here. And normally for calculation questions in an exam, they would give you the equation they want you to use. So as we know that we've got 0.03 Faradays, that's effectively telling us the moles of electrons. So moles of E is 0.03. Let's have a look at our ratio. So the ratio of electrons to oxygen is 4 to 1. So we effectively would have a quarter the amount of oxygen that you do of the number of electrons. So your moles of oxygen is 0.03 times 1 over 4, a quarter. And if you put that into your calculator, it comes out as 0.075 moles. Now you might at this point be expecting a question which asks you to convert moles into mass, and that would be a very fair question at this point. But this question doesn't actually do that. It asks you something slightly different, and because you've got a gas here, it actually asks you to calculate the volume of the gas. Now, it also tells you that the volume of 1 mole of gas is 24,000. So, if 1 mole occupies 24,000 centimetres cubed, 0.075 moles is going to occupy a lot less volume. In fact, it's going to occupy 0.075s of 24,000. Okay, and if you put that into your calculator, you come out with 100 centimetres cubed, which barely seems believable that it comes out as such a nice round number, but yeah, that's exactly what it should give. And so we come to our final question. This one is a real toughie. I think it's very unlikely you'd be asked to do something like this on an exam, but it is possible, so I will cover it. You're given a reasonable amount of information here. You're told about the current, 0.2 amps. You're told that you're passing that current through a solution for 5 minutes. Now you remember at the start I gave you an equation, Q equals IT, and I was the current in amps and T was the time in seconds. So if we're working out the coulombs of charge passed, 0.2 amps times by 5, which is times by 60, because we're converting the minutes into seconds. And if we work that out, that comes to 60 coulombs. And that very nicely is the first stage of the calculation. So we know that we've got 60 coulombs of charge. The only other thing we really know in this is that, well, 96,500 coulombs is the same as 1 mole of electrons, or 1 Faraday. So 96,500 coulombs represents 1 mole of E. Well, 1 coulomb in that case would represent 1/96,500th of a mole of electrons. So if we scaled that up by 96,500 times, we would get to that ratio. Now we don't actually have 1 coulomb, we actually have 60 coulombs. So 60 coulombs of charge is 1/96,500 times by 60. That's not too neat down there, but I'm doing my best. so 60 times the 1 coulomb amount, and if you put that value into your calculator, just searching around for my calculator, yeah, here we go. If I put the numbers in, it comes out as 6.22 times 10 to the minus 4. So that's how many moles of electrons we have. Now, if we've got the moles of electrons, we can start to use this equation here. Because this equation here tells us that 2 moles of electrons produces 1 mole of copper. Well, we haven't got 2 moles of electrons, we've got this many. But we've got a 2-to-1 ratio. So that tells us that our moles of copper is 6.22 times 10 to the minus 4 times by a half, because you have produced half the moles of copper that you did do of the electrons. So that comes out as 3.11 times 10 to the minus 4. So here are your moles of copper, and the icing on the cake, calculate the mass. Well, you've got the moles, so now turn that into mass. So use the triangle that we've used all the way through. Moles equals mass over RFM, or molecular mass. So we've got mass of copper equals 3.11 times 10 to the minus 4 times by the atomic mass of copper. So if you can find it on your periodic table, mine says copper is 63.5. Type that into your calculator, and that's 0.0197 grams. And that's your finished answer. So really this calculation is split into 3 parts. Got that part there, where we found the coulombs of charge. We've got this part here, where we converted our coulombs of charge into moles of electrons. We've got this part here, where we used our equation to find the moles of copper from the moles of electrons. And then we've got this part here, where we convert the mass into moles. Now hopefully that makes sense. The best thing to do now is to go away and do some more practice on these, check your answers, and if you're not getting them right, you need to ask for some more help. Hopefully there are no mistakes on these videos, but these are the first lot through, so I'll await the answers being checked. I hope they've been useful.